Assalamu alaikum warahmatullahi ta'ala wabarakatuh. You are all welcome to the online tutorial class. So today we are going to talk about biochemistry and pH and POH. So this pH and POH is a very large course. So we'll be starting with pH and POH of weak acids, and in further lectures we'll be talking about pH and POH of weak acid and weak bases. So pH literally means power of hydrogen. It is the degree of acidity or alkalinity of a substance. It is mathematically defined as the negative log to base 10 of hydrogen ion concentration. So this is the mathematical expression for pH. The POH is negative log to base 10 of hydroxide ion. That is, POH is equal to negative log to base 10 of OH ion concentration. And then one thing we have to keep at the back of our mind is that concentration of H plus multiplied by concentration of OH minus is always equals to 10 raised to power minus 14 molar square. So now with this we can ball into our examples. Now let's see, keep this at the back of your mind. pH is negative log to base 10 of hydrogen ion. POH is negative log to base 10 of hydroxide ion, and the product of hydroxide ion concentration and hydrogen ion concentration is always equal to 10 raised to power minus 4 molar square. This is constant everywhere, so in every solution. So now we are asked to find the hydrogen ion concentration, hydroxide ion concentration, POH and pH of 0.1 molar solution of 1 HCl, 2 NaOH, and 3 H2SO4. So now in finding pH of any solution you are given, the first thing is to dissociate it. If you dissociate it, if you have H plus, it means the concentration, this 0.101 molar given in the question, belongs to hydrogen ion. But if you have OH instead of H plus, then that concentration belongs to OH. So, but in the case of HCl, we dissociate it, we have H plus. So that means this 0.01 molar belongs to what? H plus. But now, how many H plus do we have? 1. So that means our hydrogen ion concentration will be 1 times 0.01 molar, which will still give us 0.01 molar. So that's our hydrogen ion concentration. Now to get hydroxide ion concentration, remember that the product of hydroxide ion concentration and hydrogen ion concentration is always 10 raised to power minus 14 molar square, as stated earlier. So now to get hydroxide ion concentration, divide both sides by hydrogen ion concentration. So hydrogen ion concentration will cancel hydrogen ion concentration. So I will have hydroxide ion will be equals to 10 raised to power minus 14 divided by what? Hydrogen ion concentration. And we have found our hydrogen ion concentration to be 0.01. So it will be 10 raised to power minus 14 molar square divided by 0.01 molar. So molar will cancel one of the molar, remaining 1 molar. So this divided by this will give us 10 raised to power minus 12 molar. So this is our concentration for what? Hydroxide ion. So the next question says we should calculate our POH. By definition, POH is negative log to base 10 of what? Hydroxide ion. So that means negative log to base 10 of our OH minus concentration is already 10 raised to power minus 12. So we can say negative log to base 10 of 10 raised to power minus 12, which will give us what? 12. So pH and POH has no unit. So now the next thing is we look at the pH. The pH, we say it literally means negative log to base 10 of hydrogen ion concentration, and we calculated hydrogen ion concentration to be 0.01. So we can say, okay, negative log to base 10 of 0.01, which is equal to 2. So the pH of HCl is what? 2. So now let's see another one. Now, the second one says what? NaOH. NaOH. So we can solve by saying we dissociate it as I said earlier. So NaOH will dissociate to give us Na plus what? OH minus. So in this case, we do not have H plus. What we have is what? OH minus. So that means the concentration given in the question as 0.01 molar in the case of NaOH belongs to what? OH minus, because in dissociation we have only OH minus. And how many OH minus do we have? 1. So our OH minus concentration will be 1 times 0.01, which is equal to 0.01 molar. So to get the hydrogen ion concentration, we can say the hydrogen product of hydrogen ion concentration to that of hydroxide ion concentration is going to be 10 raised to the power minus 4 molar square. So applying it here, divide both sides by 0 concentration of hydroxide ion, because we are looking for this. So if this goes to the other side, it becomes division. So now 10 raised to the power minus 14 divided by 0.01 will give us 10 raised to the power minus 12 molar. So this is our what? Hydroxide hydrogen ion concentration. Now to get the pH, remember pH is negative log to base 10 of hydrogen ion concentration. So which will be equals to negative log to base 10 of what? 10 raised to the power minus 12, which was our hydrogen ion concentration. So our pH for that is 12. So now to get the POH, we said negative log to base 10 of hydroxide ion, and the hydroxide ion concentration as calculated earlier is 0.01 molar. So when we apply it here, negative log to base 10 of 0.01 molar, we have 2. So now the next one is H2SO4. Now I want you to pay attention here. We said when we dissociate H2SO4, we are going to have 2H plus what? SO4 2 minus. So to get the hydrogen ion, that means we have hydrogen ion. So that means the concentration from the question, which is 0.01 molar, is what? Is for hydrogen ion. But now, how do we get the hydrogen ion concentration? Remember, all the ones we have been doing is 1, but in this case now it is 2. So you are going to say 2 times that concentration, which will give us 0.02 molar. So we use this relation, concentration of H plus and concentration of OH minus is equals to what? 10 raised to the power minus 14 molar. So you apply it the way we applied the other one by saying concentration of OH minus will be equals to 10 raised to the power minus 14 divided by concentration of hydrogen ion, which is equal to 10 raised to the power minus 14 divided by 0.02. So you solve for that, you get your hydroxide ion concentration, and from there you use the methods we use to get our pH and POH by using negative log to base 10 of hydrogen ion concentration or hydroxide ion concentration to get your pH and POH respectively. So this is where we stop. In our next class, we shall talk about derive the pH of water, derive the pH of weak acid, then we talk about buffers, and then we talk about the Henderson-Helsing-Bach equation, and then we say bye-bye to pH and buffers. So assalamu alaikum wa rahmatullah. Once again, Mr. Muhammad.